All right, class, now you're going to take the notes on section 4.3 using similarity to find measurements. All right, so the figures below, it tells us right away they're similar, and we're going to find some missing measurements here. All right, so we have here first A, B, C, D, E, F, all of those. Notice those are all the angles within the shape. Okay, remember when shapes are similar to each other, the angles do not change at all. They're the same in both the smaller and larger shape. So the 68, if you look at that, is in both of the parallelograms. That's the acute angle in both of these parallelograms. So if you remember, in a parallelogram, the acute angles across from each other are going to be equal. So if this one's 68, I also know that B would be 68, okay, because that is the acute angle across from it. And so would E. E would also be 68, because again, E is an acute angle and it's opposite the other 68. All right, now A, C, D, and F are all obtuse angles. And if we remember too, whenever we have parallel lines, these angles, the acute and the obtuse ones, they will end up being supplementary to one another. So to find A, C, D, and F, so A, C, D, and F are all going to be equal to each other. All we do is take 180 and subtract the 68 to figure out those angles. All right, so 180 take away 68 would leave us with 112 degrees. All right, so that's how big A, C, D, and F all are. Okay. So again, when they're similar, all the angles will remain equal. When it gets larger, all the acute ones here should match up across from each other in a parallelogram, as well as the obtuse ones. All right, so now we just have to find X. Okay, in order to find X, we can do this a couple different ways. We can either use the scale factor, or we can set up what's called a proportion to find that using our adjacent sides. So let's see. So X, notice the X is the longest side of this large parallelogram. The X is going to go with the 18.75 because those are the longest sides of my two shapes. Okay, and then we know then the shorter sides, those two would also pair up with one another. Okay, so I'm going to show you another way. I'm going to show you how to set up a proportion to find this. So what we can do, we can set up a proportion where we put the small side over the long side of the adjacent sides here. Okay, we're going to put the adjacent sides together. Okay, so if I look at this small parallelogram, okay, I'm going to put the short side over its long side. I'm going to put 12.5 over 18.75. Okay, I'm putting the short side over the long side of this one. And that should be equal, if they're similar, it should be equal to the short side over the long side of the big one. So short over big, or small over long, and I'm going to do the small one over the long one here. I'm going to do 27.5 over X. Okay, so short over big, short over big. I did for both of them, the small side over the long side. Okay, so now we can solve this proportion a couple different ways. What we can do is we can either find the scale factor between this. How do we go from 12.5 to 27.5? Okay, which is not necessarily an obvious scale factor, but if I take my calculator and I divide, okay, if I go ahead and divide 27.5 divided by 12.5, I see that it goes in, oops, did I write that right? Yeah, 27.5 divided by 12.5. I did that right. Okay, it goes in 2.2 times. I'm missing here. Okay, and then if I do 18.75 into this one, if that goes in 2.2 times, then this one should also go in 2.2 times. So I can take the 18.75 times 2. Oops, type that in again. Sorry guys. Okay, 18.75 times 2.2. And we get 41.25 when we type that in. So x would equal 40.